Hello friends, welcome to Code Sutra. In this video, I'll be solving LeetCode problem number 744, smallest letter greater than the target. In this problem, we are given a target letter and we are given an array of letters. The two key things is the array is sorted here, and what we have to do is we have to find the letter greater than the given letter. Say for in this example, which is the letter greater than F, that is H. Right? See, though F is there in this array, we have to find the next letter that is greater than that. Obviously, the first idea would be linear search. How do we do it? We go from the first, that is we check every element. If that element is greater than that, we will return that element. If we don't find the answer, the idea is we will return the first element of the array. So let's dive into the solution. Definitely it's very easy to find the solution using binary search, but let's develop the intuition how we actually came at binary search and how actually our brain works to solve this problem. Let's see. Suppose we are given the target letter as H and we have to find the letter greater than this in this particular array. So how did your brain try to find the answer here? Did it just go on every element and found the answer? No, right? What it does is it picks up a random element here. Say for example, it picked up D and it eliminated all the letters that are left to D. Why? Because if D is already lesser than H, what are the chances that it will be on the left side? 0, right? So what your brain did was it safely eliminated all that was on the left side of H. Similarly, it will pick up one more random letter. Say it picked up X. What are the chances it will be on the right side of X? It's 0, right? So it can now safely eliminate this. So this is how your brain actually found. So let's use the same concept to find the answer here. How we will do? We will use something called as binary search. Instead of just picking up a random element, what we can do is we can pick up the middle element. So how do we do that? We compute the middle element to be equal to the starting, that is 0 plus 16 and divided by 2. What is that here? It is 8. So we go to G and we see, is G lesser than or greater than H? It is lesser than, right? So what we do is we can safely eliminate all that is on the left side of G. So we will eliminate all of these elements. Then this will be our search space, whichever is on the right side. Again now our left will be equal to 8 and our right will be equal to 16. Again we will find the middle element. What will be the middle element? It will be 16 plus 8, that will be 12. So we will again go and look at J and we have found our answer, right? Why? It is greater than that, so we can safely eliminate whichever is on the right side. We can eliminate all these elements whichever is on the right side. Though we have found the answer, can we stop it there? No, right? The answer can still be on the left side. So again we do it. Our right will now get updated to 12. Instead of 16, it will now be equal to 12. So now again we find the mid element. The mid element will now be equal to 10. Now what do? We go to G and we find that G, again we can eliminate the left search space. So we eliminate these both elements and our left will be equal to our 10 and our right will be. So again we go to the 11th element, that is I. And here we can again eliminate whichever is on the right side. So we eliminate all that is on the right side. So we are just left with two elements now. Left will be 10 and right will be equal to 11. So again we will find the middle element, that is G. So since G is lesser than that, we can eliminate this and we have only one, that is 11. So 11 will be our answer. So let's dive into the coding part of this. What are we doing here? We are initiating left equal to 0 and right is equal to n minus 1. That is the length of the array minus 1. And while left is lesser than or equal to right, what we do at every point we find the middle element. And if the middle element is lesser than t, we update, that is we are eliminating the left half of the search space. And if it is not, we will just eliminate the right half of the search space. So that is the core idea of binary search. So whenever the array is sorted and we can eliminate part of the search space, we will be using binary search. Finally, we will return the answer. Thank you for watching the video. Please do like, share and subscribe.